In this episode, we're going to look at how to configure and verify network time protocol. I'll show you how to do it, and we'll talk about the concepts along the way. Network time protocol, also known as NTP, synchronizes the time of day among a set of distributed time servers and clients. While there are a number of applications that require synchronized time, we're going to focus on correlating events that are listed in the system log and other time-specific events from multiple networking devices. NTP uses the User Datagram Protocol, or UDP, as its transport protocol. All NTP communications use the Coordinated Universal Time, or UTC. An NTP server usually receives its time from an authoritative time server, such as an atomic clock attached to a time server. The NTP server then distributes this time across the network. NTP is extremely efficient. No more than 1 packet per minute is necessary to synchronize 2 devices within a millisecond of each other. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 10.3.4 Configure and Verify NTP. I got the Packet Tracer file open. On the left side, I have our work area with our topologies. That's what we'll be configuring our devices. On the right side, I have our instructions. The way bottom right is the Packet Tracer activity window that opens up when you open up Packet Tracer. On the upper right, I have a Windows document of those same instructions. Reason I have that, there's a question we need to answer. Having the word document lets me put my answer in there and save that document. We have our setup. We have the server here. This will be our NTP server. We have a switch that connects 2 routers up to that. These 2 routers we're going to set to sync the time to the server. In our addressing table, we have IP addressing information. In this activity, we're going to configure NTP on R1 and R2. Instructions, step 1, NTP server. Server N1 is already configured as the NTP server for this topology. Verify its configurations under Services NTP. I'm going to come over here, click on the server. And on the Services tab, click on that. Down the list, we have NTP, a little over halfway down. Click on that, and then we can see NTP is enabled. This is the clock on our server. It's showing that we are on October 12th, 2019 at about 11 a.m. So October 12th, 2019, which is a Saturday, at about 11 a.m. Then on to step 1B. From R1, ping N1, our server, to verify connectivity. On R1, I'm going to make the window a little bit bigger going right to left. Click on my CLI tab. Hit enter, type in enable to get into privilege exec mode, and then we will ping our server. So ping 209.165.200.225. Okay, first ping failed. Cisco operating system, we're on a router here, sends out 5 echo requests. Expects 5 echo replies back. We can see that the number here we're sending out is 5. First symbol that came back is a period. The period says the ping request or ping reply never came back, so that timed out. But then the next 4 worked. What happened here? What happened? Erase that. Start over. What happened here is the first ping request we sent out, we had to do some ARP lookups to get the MAC addresses to be able to communicate and forward our packets. By the time it was done doing the ARP request, that ping request timed out, and that's our failure. The next ones all worked because we had all of that ARP done. It was in our ARP cache. Now, to verify that, what I'm going to do is I'm going to repeat the command, hit up arrow once, hit enter. All 5 pings worked. That takes care of step 1B. Step 1C, repeat the ping to N1 from R2 to verify connectivity to N1, our server. Jumping on R2 here, sliding up, making a little bit wider, right to left in my CLI, enable to get into privilege exec mode, and then ping 209.165.200.225. Looks like the first one failed. Had to do an ARP lookup again. Next four did. I'm going to repeat the command, up arrow, enter. All 5 worked. So we are able to ping our server. On to step 2, configure the NTP clients. Cisco devices can be configured to refer to an NTP server to synchronize their clocks. It's important to keep time consistent among all devices. Configure R1 and R2 as NTP clients so their clocks are synchronized. Both R1 and R2 will use N1 server as their NTP server. Something important to note, a lot of your networking devices, not just your networking devices, use NTP. It's nice to have all of that synced together, from your servers to your client time clocks to your wall clocks to the punch card systems. Nice to sync all of that together. Check the current NTP and clock settings as shown on R1 here. We're going to do a show NTP status. Show NTP status. Coming back and it tells us NTP is not enabled. Next command is a show clock detail. Show clock detail. Coming back and it's telling us our time is about 2300 hours, about 11 o'clock at night, on Sunday, February 28th, 1993. So the year that our router thinks it is 1993. That's the default time. If your device doesn't have anything, it's going to time out to it's going to pick a date from a long time ago. Then once you synchronize it, it should be the date you're synchronizing. The other thing we have here is time source is hardware calendar, meaning we synchronized our time. We're using our own internal clock. We're not using a server. On to step 2B, configure R1 and R2 as NTP clients. Use the NTP server command to specify the NTP server. Okay, to set our NTP server, we do that from global configuration mode. So type in config T. Then the command we are using is NTP, and then we want to specify what server do we want to synchronize to. So it's server, and then the IP address of that server. And that was our N1 server. And that address again was 209.165.200.225. That sets our R1 router to look to that server, which happened to be N1, our NTP server, to synchronize its time. I'm going to go ahead and type exit here. And then let's go ahead and repeat this configuration on R2. I'm going to minimize R1 here. Click on R2. Get into global configuration mode, so config T, and then the command was NTP server, and then the IP address of 209.165.200.225. That's our R2 to look to that server to synchronize its time. Type exit, take me back to privilege exec mode. That takes care of step 2. On to step 3, verify NTP settings. Check the clocks on R1 and R2 again to verify they are synchronized. I'm going to go back to R1. And we're going to check the clocks using show clock and then detail. Show clock detail. Didn't come back. What I'm going to do is I'm going to hit the fast forward button down here. Click on it. I don't know, I clicked on it like 10 times. Let's go back. Let's enter that same command again, up arrow, enter. And now our time is about 11 o'clock in the morning. Remember, that's the time we had on the server. And then we are Saturday, October 12th, 2019. So that is the date and time that is now set on our server. Notice I had to wait for the NTP process to synchronize. What I did is I clicked on the fast forward button. That's this button down here towards the bottom left. 2 triangles pointed right. I clicked on it. I'm impatient, so I clicked on it like 12 times. I repeated the command a second time, and now it's saying this is our time, and then the second line says time source is NTP. Before it said time source is hardware clock, we were using our own internal clock, but now we're synchronizing to an NTP server. Okay, let's check R2. I'm going to minimize R1, open up R2, and let's do that show clock detail command again. And here on R2, we can see our time is 11 o'clock in the morning, Saturday, October 12th, 2019. Once again, that was the time from our server, and we are saying our time source is from an NTP server. We're setting it from an NTP server. I'm going to actually put these side by side. So here's the R2 window. Here's the R1. We can see that they are synchronized to about 11 o'clock in the morning. I ran these at different times, so maybe it's off by a little bit. If I do an up arrow once in R1 and then do it right away in R2, the time should be pretty close. So R1, R2, we have 11:15:4 in the morning on R1, and R2 11:15:5 in the morning. So really close. The dates are the close. We're synchronizing with the time server. Are the clocks synchronized? Yes, they are. On to step 3B. Check the NTP status and NTP associations by using the following commands. Okay, on R1 here, first command we're going to do is show NTP status. Gives us some information here. The important part for us is saying our clock is synchronized. So that means we are connecting into a server. This is a Stratum 2 server, meaning there is the atomic clocks, Stratum 0. Then we have our N1 NTP server that we're connecting to. That's a Stratum 1 server, because they are directly connected to that Stratum 0. And then we are now, this R1 is a Stratum 2, meaning we're connected to a Stratum 1. There's one device between us and the atomic clock. So our important thing is we're synchronized, and then it also tells us what our server is. 209, 165, 200, 225. That's our N1 server. The other command is show NTP associations. Here it's going to give us all the NTP servers that we're getting our times from. Right here is the IP address that we're getting to. Its reference clock, the 209.165.200.225, our N1 server, its reference clock is 127.127.1.1. It's its loopback address. Remember, the loopback address is all of the 127.0.0.0 addresses. So 127.0.0.1 all the way up to 127.255.255.254. And that number falls right in there. So it's referencing its own clock. Because it's a lab, it's a little strange. Normally it would be, because that's a Stratum 1, it would somehow reference an atomic clock or GPS clock, however you're getting your time. And let's quickly check R2. R2, first command is show NTP status. We are synchronized. We are a Stratum 2, and we are referencing our N1 server. And show NTP associations. Once again, our time server is the N1 server. It's referencing its own internal clock again. Once again, it's just a little weird because we're in a lab. Otherwise, it would say something. It would somehow refer to the atomic clock, GPS clock, something along that line. That was Packet Tracer Lab 10.3.4, Configure and Verify NTP. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.